Hello. In this video, we'll continue looking at probability. I have a question here. In a box of 10 bulbs, 3 are fault. So a box has got 10 bulbs. And they're saying out of 10, 3 are fault. Let me use F. 3 are fault. If 2 bulbs are drawn at random, one after the other, find the probability. So if the 3 are fault, the remaining 7 must be good, isn't it? So that we have the complete set out of 10. So before we answer question 1 and 2, let's understand what a tree diagram is. It will enable us to understand this question 1 and 2. So we have 2 selections. We have the first selection. They are saying it's one after the other. When they say one after the other, it means without replacement. That means when they picked one bulb, they didn't take it back. Let's call this is a box. They picked one bulb, they put it inside. Another one was picked after the other, it was put inside without taking them back. That is without the replacement. Now here are some of the things that you need to know when it comes to without replacement. The first selection is not affected. Second selection is affected, including the totals. So in this case, we have a total number of 10 bulbs. So this is the total number of bulbs we are going to have in the first selection. So let me do this. That's our first selection. Then we have our second selection here. So this is our first. Let me do this. Then this is our second selection. So in our first selection, we have good and fault. So good, we have 7 out of what? Out of 10. So we are going to write 7 out of 10. Then for fault, we have 3 out of 10. Now, since 2 bulbs were picked, we don't know which one. We assume, we say, what if green also, what if another one good bulb was picked, also another good bulb was picked? So if we go from G to good, what happens? In the first selection we have 7 bulbs. That means in the second selection we can't have 7 again if good has to be picked, so it will remain 6. Now if good remains 6, here the total was 10. The total can't remain 10 again. The total remains 9. So that's what we have in there. If you picked good and good, so here we have 6 over 9. But if you picked green, sorry, not green, good and fault, these are 2 different. Hence, for fault, it remains 3. Take note, it remains 3 because these are 2 different, but the total remains 9. This is acting as a first selection for fault. Even here, if you picked fault, then then good. Pardon me, green is in my mouth. Fault, then good. So good will still remain the way it is at first, 7, but the total will be 9 because this is playing as its first selection. But if you picked the same color, the same type, which is fault and fault, fault will be reduced by 2, then the total also will be by 9. That's what you must know in this case. So in the second selection, the total should always be out of 9. Then if you picked good reduces by 1. But if you pick different, fault does not change. It remains 3 the same way it was, but the total remains like that. If you pick fault and good, this is acting as the first selection for good and the first selection for bad. So what happens? Good remains 7, but the total remains 9. But if you pick both fault and fault, it now reduces by 2 and the total still remains 9. Now we can answer our questions. So question 1 says both are good. So probability That's how you do. Open brackets of good, because they are both good, remember, is equal to, so this is equal to probability of good. Now both means multiplication in probability, times the probability of another good. So in this case, we have the probability of the first good is 7/10 times the probability of the second in the second selection is 6/9. So we have to reduce this. Now remember, 7/10 times 6/9 is the same. When you do 6/9, it's the same as 2/3. Now what we get here is the final probability, which is equal to, now we need to multiply 7 times 2, which is 14, divided by 10 times 3, which is 30. We still have to reduce it to the lowest possible value. So we know that 2 can go into 14 7 times, 2 can go into 30 15 times. Hence, that's the probability in this case. Both means multiplication. Now, this case says one is fault and the other is good. So, they haven't said which one is at first here. So take note. They haven't said good should at first or fault should at first. As long as we have one fault and one good. We have one good here and one fault here. Okay, it's going like that. We also have another fault, then good like that. So we have actually two possible outcomes. So we have the first one is GF. The first one is GF or FG. Now we need to work out GF. If that is G and F, we have 7/10 times F is 3. 3/9 is the same as 1/3. Remember, when you reduce it, or means plus. FG, we go to where F is 3/10. 3/10 times G, so we're going like that, another like that, so 7/9. So now I have to multiply. 3 times 1 is 3, not 7, not 3, sorry. 7 times 1 is 7 over 30, which is equal to plus 3 times 7, we get 21 over 10 times 9, we get 90. I need to find the common denominator here, which is 90. 30 into 90 is 3 times. 3 times 7, we get 21. Plus 90 into 90 is 1. 1 times 21, we get 21. This will be equal to 42 over 90, which can be reduced to 2. 2 into 42, we get 21 over 2 into 90, you get 45. So that's the answer. So thank you so much for watching. In case you have any questions, please don't forget to ask or drop in the comments there. So I'll see you in the next video. I'm Previous Tutor.